Good day to all of you, and I welcome you all in this course on Introduction to Engineering Thermodynamics. In the previous video, we have talked about the system and the various types of system. We have seen the definition of the system and we have seen the examples of the system. In this video, we are going to discuss about the properties. We will start with the thermodynamics properties of the system. Then we will talk about the state. After that, we will talk about the processes. Later on, we will come to the point of thermodynamic cycle. And lastly, we will talk about the thermodynamic equilibrium. So let's begin with this and we'll start with the thermodynamic properties of a system. The properties of a system is measurable characteristics of a system that is in equilibrium. And every system has certain characteristics by which its physical conditions are be described. And these physical conditions or the characteristics are known as the properties of the system. For example, temperature, volume, pressure, these are the example of the properties. And the properties can be of two types. One is of the intensive property, and intensive properties are those properties which are independent of the mass. So these are the independent of mass. That means these properties does not varies with the mass. On the other hand, if we talk about the extensive properties are those properties which varies with the mass. So varies directly with the mass. The example of the intensive properties are temperature, pressure, density. So these are the few examples of the intensive property. On the other hand, if we talk about the extensive properties, the example for these are the mass, volume, energy, enthalpy. So let's more understand about these properties and take an example of a room or a container. Let's say we are having a container, and in this container we are having a properties. Let's say the properties of this container is the mass is m, pressure is p, volume is v, density is rho. Now we will divide this room into the two parts, two portions. So here we have divided this room into two parts. So we can see here is that mass will become half. So half portion will having the half mass. So this will be a half mass. On other half portion will also having the half mass. Half volume and other portion will having the half volume. But pressure and density are the same in both portions. So here density will be rho and the pressure will be P. And if we talk about the other half portion, in that condition we are also having the density is rho and pressure is P. So we can say that mass and volume are the extensive properties. On the other hand, density and the pressure are the intensive properties. I hope that you've understood about the properties of the system. Now let's talk about the specific properties. The ratio of any extensive property of a system to that of the mass of system is called as an average specific volume of that property, and also known as the intensive property. Let's take an example. Let's talk about the energy. Energy usually represented by the capital A, and According to definition, we have to divide this energy by mass. So E by M. So it will become your specific energy. So if we know that the unit of the energy is joule, so unit of the energy per unit mass will become your joule per kg, and this is your specific property. So because it is coming per kg. And similarly, if we talk about the volume, so volume is again a extensive property, but if we divide by n, so it will become your specific volume, and the unit will become the meter cube per kg. So this is about the specific property. Now let's talk about a state. A state is a set of properties that describe the condition of a system. Example, mass, temperature, volume. Let's elaborate more to this state. Let's take an example of the piston and cylinder arrangement. Let's say we are having the piston and cylinder. This is your cylinder and this is your piston. And this piston can reciprocate in this cylinder. And in this arrangement, we are having the gases. And the initial state is describing by the pressure P1, temperature T1, and volume V1. Let's say initially this fluid having the pressure P1, temperature T1, and volume V1. And we are taking the example of the expansion. Let's say this gas is expanding in the system. So after the expansion, we are having this condition. Let's say this piston move upwards and this gas is expanding in this volume. So here we can see that the volume is changed, temperature is also changed, and the pressure is also changed. So here the pressure will be P2, temperature will be T2, and volume will be V2. So these are the properties, or these are the set of properties. P1, T1, V1 is the set of properties that describing about the system. Similarly, P2, T2, V2 is also the set of properties and describing about the final conditions. So this is about the state. These are the set of properties. Now let's talk about the process. So process is a change from one equilibrium state to the another equilibrium state. So the series of states through which a system passes during a process is called the path of the process. Let's take an example again. Let's say we are having a piston and cylinder arrangement again. So this is the initial state. And this initial state is describing on this thermodynamically plane by I. Okay, here we are having the I state. And this piston will move in this direction and it will come to here. It will come to here also and it will come to here also. Let's say this is its final stage. So let's say this is the final stage. So as we can see here, the piston is moving from initial state to final stage and taking lots of states, lots of equilibrium states. So these are, let's say, these are 1, 2, and let's say this is 1 and this is 2. And if we draw a path here, and that path is known as the process. So this is your process. So as the definition suggests, change from one equilibrium state to the another equilibrium state. So here we can see that the piston is or the fluid is changing its state I to state F, and in between we are having the infinite states, and the path that is taking from all the states is known as the process, and this is known as the path also, path of the process. path of the process. And this process can be of constant pressure. If this is taking place at the constant pressure, we call it as the isobaric process. If it is taking place on the constant temperature, then we call it as the isothermal process. If it is taking place on the constant volume, then we call it as the isochoric. And if it is taking place at the constant entropy, then we call it as the isentropic. Similarly, there are lots of properties that you can make the constant, such as the enthalpy and the other properties. Now let's move ahead and talk about the cycle or the thermodynamic cycle. A thermodynamic cycle is defined as a series of states changes such that the final state is identical with the initial states. To understand, let's draw a thermodynamical plane. And let's say initial state is describing by the I. At initial state, it is having I and it is having the properties, let's say Pi, Vi, Ti, and it is going from I to 2. And again, it is coming from 2 to final state, that is the I. So here, I and F are the initial and the final states. As the definition suggests, that state changes such that the final and initial states are the identical. And here we can see also initial and final states are identical because the fluid or substance is repetitively coming at its initial positions or repetitively coming its final position. So that kind of a process or that kind of a system or that kind of a cycle, we call it as the thermodynamical cycle, and that cycle rotates or the fluid comes its initial position again and again. Let's move ahead and talk about the thermodynamical equilibrium. A system that maintains thermal, mechanical, and chemical equilibrium is known as the thermodynamical equilibrium. On the other hand, if we talk about thermodynamic equilibrium, we can say that a system is said to exist in a state of thermodynamic equilibrium when no change in any microscopic property is registered if the system is isolated from its surroundings. So basically, thermodynamic equilibrium made up of 3 equilibrium. One is your thermal equilibrium, second one is your mechanical equilibrium, and third one is your chemical equilibrium. Thermal equilibrium means there is no change in the temperature. So thermal equilibrium means no change in temperature. Mechanical equilibrium, it means there is no unbalanced force in the system. So no unbalanced force available in the system. And lastly, if we talk about the chemical equilibrium, that means there is no chemical reaction. No chemical reaction or no mass transfer or no matter transfer. So when these 3 equilibrium occurs, then we call it is a thermodynamic equilibrium. So I hope that you understood about the properties, state, process, cycle, and thermodynamic equilibrium. Thank you very much. Have a nice day, and God bless you to all of you.